All right. First off, welcome everybody to Engineering 102. My name is Dr. Michelson, and in addition to being your Associate Dean here in the college, I'm going to be your instructor for the wonderful world of computer-aided drafting. Real quick on a logistical item, if you have not yet, please scan the QR code on the screen with your phone. It's going to take you to a Google form that's basically going to be used for attendance, but on this form, I'm asking some other questions about what type of laptop you have and whether or not you've had a chance to install AutoCAD. I'll pull it up again here at the end of class, but if you have a chance, go ahead and scan that now. Has everybody been able to do that? Okay, awesome. Okay, so let me pull this up. Okay, so again, welcome to the introduction to CAD. Like I said, I'm going to be your instructor this semester. Since this is, most of you are first-year students, and I didn't teach any first-year classes in the fall. For most of you, this is the first time you've had me. So, of course, I'll say a little bit to introduce myself, and I'm going to violate a PowerPoint rule by showing you my best slide first. This is my family, and I have here a picture of my daughter Stephanie. That one up top is her with the jolly guy from Christmas. This was over winter break, and then that's my wife at the bottom. And see, that's Stephanie when she was a baby, and she was supposed to stay a baby, and she didn't. That's how big she is, and she keeps getting bigger, and that's a problem because she was supposed to stay a baby. So before we begin, if there's anybody that has any ideas on what I do about that, just see me after class because I really need to figure that out. That was a joke. Not very funny. All right. Like I said, I'm the Associate Dean here in the college in addition to being the instructor for the class. So I usually handle registration issues. If you have any issues with financial aid, you're probably seeing me. I produce a graduation list. I tend to handle all the academic business here in the unit. So if you ever need anything on that end, you're more than welcome to see me. I did go to that school up north. I have my PhD from WVU, and I am a registered professional engineer here in the state of West Virginia. I am a civil engineer by trade, but my specific area of expertise is in structural engineering, bridge engineering, and steel design. So a lot of what I do on the CAD side, while I am a bridge engineer, I do a lot of steel detailing and drawing and whatnot. So I kind of straddle a little bit of both sides of the fence between civils and mechanicals. And for you biomedicals in the room, biomedical drawings and mechanical drawings are very, very, very similar. So really the two, civils and mechanicals, are what's different. I want to make sure that everybody is oriented as to where my office is, in case you don't know. So I have here a floor plan of the engineering building. If you're in the lobby on the second floor and you're facing 3rd Avenue, on this side of the building, there's that little area with the couches and tables and whatnot. If you go down the hallway on this side, there is nothing down that hallway but the dean's office, okay? And I'm in that office. So just from where you're at now, if you go up one floor, go to the other side of the atrium, down that hallway, I'm the only person down there, okay? Room 2103, and I'm 2103A. So I'm pretty easy to find in that regard. And our IT guy is also in that office as well, and I'll mention him here a little bit later. I do a lot of work in terms of my research, like I said, with bridge design. I've done a lot of work with developing short span bridge solutions. So even in my research, I'm doing a lot of three-dimensional modeling and whatnot. This is some computer modeling of some structures that I've done as part of my research. And so I even to this day still use some of the skills that I learned when I took CAD close to 20 years ago as an undergraduate student. Before I get into the course operation, I can't help but tell you a story about this because I want to illustrate what an engineering student could be capable of with the skills that you would learn in this class. So I used to work at an engineering firm back home, and we used to offer general civil engineering services and surveying services in the area. And we got a phone call one summer, and the phone call we got was on a Tuesday. And what was going on was there was a small little like outlet mall. It had like a Kroger's, like a Family Dollar. You probably kind of get the idea of what I'm talking about. It was in Princeton, and there was a real estate deal going down where the place was going to be sold. It was about $15-16 million deal, something like that. And I don't remember if that's the exact number, but the scale is probably pretty reasonable. We got a phone call on Tuesday that the lending agency essentially said we need an updated survey of the site, an updated drawing of the site in order to approve the loan, right? They told us that on Tuesday, and they said we need the drawing by Friday. So what I had to do was, we had to go and do our deed research. We had to look up all the adjacent property owners. We had to go out there Wednesday, go out there Thursday, and collect all the data. And then what happened was on Friday, this was when I was a little bit younger and more used to consuming Monsters and Red Bulls, I came into the office about 6:30 in the morning, and in about 6.5, 7 hours, I drew that, okay? I drew that, and then we went through 2 rounds of revision internally within the office, and we got the drawing done by close of business on Friday. And then the deal fell through and they didn't buy the property. So we got paid, but but the point I'm making is this is a drawing that I produced really with the skills that I learned in a class like this. Like my goal with my instruction in this course is to do my best to repeat the instruction that I had as much as possible, right? So this is kind of what I want you to be able to produce at the end. I'm not saying I'm going to give you a homework assignment of this complexity in this class, nor did I have one when I took CAD. But a lot of the features that you see in this drawing, just lines, text, hatches, annotations, so on and so forth, these are going to be the skills that I try and teach you this semester. And so I just want to show you what I think you can be capable of as engineers. I don't think you need to be experts. I think you need to be proficient, and that's my goal. I don't think expertise comes unless you practice it and use it a lot, okay? So, but we'll get to that stuff here in a bit. All right. What I want to do today, my goal today, is really logistics and how the course is operated. I'll talk a little bit about why you're in this class here in a little bit, but I want to talk about how the course is going to be operated. We got a really big class, and this isn't the only section. I got a section at 11 a.m. that's bigger than this one, right? We got a lot of students in CAD this semester. I got about 120. So I want to make sure that we're operating the class in a manner that's clear for everybody. I believe that CAD is a science that is best learned by doing. So the homework in this class is the biggest component of the grade, okay? That's a typo, because that's supposed to be 20 and 20. I don't know why that says 15 and 15. That's supposed to say 20 and 20. I just noticed that. That's supposed to be 20 and 20. I'm sorry. Here I am, day one. Got myself a typo. Marshall University policy says I'm allowed 7 mistakes per semester, but then again, I'm the one that's keeping track of the mistakes, so it's a corrupt system. I'm well aware of it. See, it's first day. I'm going to try and get some laughs out of you. The attendance is worth 15%. The homework is worth 45%. I use the word homework a little bit loosely because I'm trying to design the exercises such that they can be completed in class, or as much in class as possible. And that'll become clear when we start talking about the operation here in a bit. We do have 2 exams, which, by the way, I don't know if anybody told you, but we do not have exams in college. We have celebrations of learning. So we are going to be celebrating twice this semester, and then I'll talk about what we're going to do for the final here in a little bit. There is no textbook in the class. I'm not going to make you buy a textbook. I am, however, going to require you to bring your laptop, okay? So if you didn't bring your laptop today, that's fine, but I do need you to be bringing it to class from here on out. And for the vast majority of classes, we will use it in class, okay? I do strongly suggest that you have a mouse. May I borrow this real quick? I do strongly suggest that you have a mouse with a physical wheel, okay? Not a mouse with like a trackpad. So for example, I'm broadcasting this on a Surface, and I have a Surface mouse, and it's got this sort of like touchpad for the wheel. This is not good for CAD, just point blank. I strongly recommend that you have a mouse with a wheel because you can scroll the wheel to zoom and you can press in the wheel to pan images. And being able to pan and zoom quickly with the mouse will save you a lot of time on homeworks and exams. So I really strongly recommend it, okay? I do strongly recommend Windows, to be blunt. If you have a Mac, we can make it work, but Windows does help. I'm just going to be honest. The other thing that you will need is an engineering scale. This is different than a ruler. An engineering scale, it sort of looks like a ruler, but it's like triangle shaped and it's got different scales on every side. We don't need that right now. So if you don't get that for a couple of weeks, it's not a big deal. You can buy those on Amazon. They're like 10 bucks a piece. It's not a big deal. We won't start using that until around like week 7, something like that. So we've got time on that. Attendance. So attendance is going to be collected at the beginning of every lecture using those QR codes at the beginning. So today's QR code had like questions about Mac and Windows and AutoCAD and all that. Most lectures is just going to be give me your first name and give me your last name. It's just going to come in, put your name in, go. Make sure that you come on time because I am going to pull the QR code up at the very beginning. I'll probably leave it up for a minute or two as I go through announcements, and then we're going to get right into it. Okay? So make sure that you come on time and make sure you stay for the total lecture. And I'm going to talk a little bit about that because that's actually really for your benefit. Let's talk about the lectures themselves. I am going to record the lectures and post them to YouTube. Okay? If you check Blackboard right now, you will see a link to a YouTube playlist. I'm going to record the lectures, which will have the screen capture and then the microphone. I'm using a podcast microphone here, which should pick up, what I'm saying here. I'm trying to be somewhat loud so it can pick me up. And I'll post those to YouTube. I might not post them immediately, but I will post them. And just so everybody's aware, I'm literally doing this same lecture twice. Okay? So I did this, everything I'm saying right now, I just said 50 minutes ago. So I will probably only record one of them. It might be this one. It might be the previous one. Excuse me. I put on the slide that I said I would probably do the 12 p.m. one. But I just realized that on Mondays and Wednesdays, I have 3 classes, and this is my 3rd one. My voice is going out a little bit, so I might do the first one, just so that my voice is a little clearer on the recording. But I'm using the same notes and the same content each time, so as long as I'm recording one, that should be sufficient. Homework. Okay, so the way homework is going to work is the homeworks are intended to be completed in class. So I'll go through this in more detail, but the way Wednesdays will work is I will give you an in-class exercise that you will then go through, and the idea is that the result of that in-class exercise is a drawing file that you submit, and that's your homework, okay? So the idea is that you come in at noon, start working on your exercise, and if you get it done by 12:50, upload it, and then your homework's done for the week, okay? That's kind of the idea. Now, what I'm going to do is I'm going to leave the homework submission open until 5 p.m. the following Monday. Okay? There are a couple of reasons for 5 p.m. the following Monday. One is that if you don't get the homework finished on Wednesday, I want to give you time to work on it. We're going to talk about Fridays here in a bit and me being available for you then. But also, during Monday's lecture, I will probably ask, how did last week's homework go? And if there are any big problems, we can work through them then. So that's why I'm going to make the homework due on Monday, but like a little bit later in the day. I will accept homework late, but it's 20% per day. I'm hoping that that's not really a big deal with the nature of how the homeworks work in this class, but I'll tell you that once it's graded and returned, I'm not accepting them. It's really not in your interest to not get the homeworks done, because the way AutoCAD works, it does kind of build on itself. So if you're falling behind on one homework, the next homework might be more challenging and so on and so forth. Again, though, as I said, they're designed to be completed in class. Okay? Let's talk about celebrations. Again, we don't have exams in college. We have celebrations of learning. We're going to be celebrating twice this semester, one in week 6, one in week 10. Okay? They are not intended to be comprehensive. Some material will carry over from previous exams, so if we're focusing on drawing lines, well, you're probably going to be drawing lines on both exams. We can't really get around that. But they are intended to cover the specific areas in those exams. Okay. exams are not intended to be time critical, okay? What I mean by that is I build the exams and then I take the exam. And the idea is if I can take the exam in 20 minutes, you can take it in 60 minutes. And I call that a rule of three. I've used a rule of three for a very long time as an instructor, and I tend to not really get too many complaints about my exams being too long, okay? So when I became a professor, I made a list of all the things that used to bug me when I was a student, and I said, I'm not gonna do that. And one of the things that used to bug me is when I would have a professor who would give me an exam that takes 4 hours to do and say, here's 50 minutes. I never really liked that. So I try and not do that to you all. Now, some of you are probably doing the math and going, well, if there's 2 exams and one's in week 6 and one's in week 10, what about final? I'm not going to do a final in this class. And to clarify, what that means is I'm not actually going to do a final exam meeting during finals week. Instead, what I'm going to do is I'm going to have probably a somewhat culminative assignment in Inventor due during the Wednesday of that finals week. So Inventor is going to be our 3-dimensional package, and so we're going to spend a lot of time learning how to draw parts in Inventor, and it'll probably be a final assembly, and an assembly is just a bunch of parts all together. So you'll do that and submit that during finals week. So that way you don't have to meet for a final exam in here. Sound good? All right. Okay, so I'm going to change gears a little bit and talk about how we're going to operate the course, but in terms of grades and how the grade's going to be calculated. Any questions? Okay, talk about technology. First off, Blackboard. I'm going to use Blackboard pretty heavily in this class. It's going to be used to report all the grades, all of the lecture notes, homework assignments, in-class exercise, all that stuff is going to be posted on Blackboard. I'm going to pull the course shell up here in a little bit so you all can kind of see how I plan on doing it. Bless you. The exams will be conducted by Blackboard. Now, I want to be crystal clear as to what I mean by that. We are going to do the exams in person here together, but you're going to open up the exam on Blackboard and submit your file on Blackboard. So like our first exam will basically be a test of your skills in AutoCAD. And so you'll have the exam, you'll have something you need to produce, and then you'll upload your file to Blackboard. And that'll be the, that's how the exam will be submitted. So you'll need your laptop to do it, and you'll be able to submit the exam via Blackboard, but we're doing it in person. Okay, does that make sense? Everybody okay with that? Teams. I do plan on using Teams somewhat regularly throughout the semester for the purposes of periodic announcements. There is also a chance that as we get a little bit later in the semester, we might have some CAD assignments that are a little bit more challenging than others. And so what I might do is I might say, hey, I've got a lot of questions about homework 4. So let's post a little thread for questions on homework 4. So that way, if you have a question about something in homework 4 and I answer it, everybody else sees that answer so that we make sure that everybody's got it. Because I want to make sure that you all are having as easy of a time doing it. I don't want to try and get in your way. So I might use Teams in that regard. We'll see how the exam or how the homeworks go. That part will maybe be a little bit organic. And Teams can serve up as a backup lecture in case, I don't know, we have some crazy weather or something. I just want to make sure that if you have not yet already installed Teams on your laptops or maybe the app on your phone, I would go ahead and do so. Okay. We do have 2 software packages we are going to use this semester. One of them is AutoCAD and the other is Inventor. Both of these are Autodesk products, and I'm not trying to be a shill for Autodesk or anything by saying this, but I think it's fair to say that AutoCAD is one of the most ubiquitous and well-known computer-aided drafting programs that there is. It's the oldest, probably the most well-known, etc. I think it's fair to say, and I think even the folks at Autodesk would admit, AutoCAD was primarily intended as a 2-dimensional program, and 3D, while it can do 3 dimensions, 3D was maybe a little bit more of an afterthought, whereas Autodesk Inventor was really intended from square one to be a 3D program. Okay, that's really what it was intended to be. Now, just to attack the elephant in the room, Inventor is not Mac friendly, AutoCAD is. And so here's what I mean by that. There is an AutoCAD for Mac version that you can download and install right now, and I have no problem if you do that. Mac does not have an Inventor program. Now, dependent upon how many students have Macs in here, I might be able to set up some virtual machines so that you don't have to go and buy a Parallels installation or something like that. But I will mention that I did speak to the instructor who taught 102 last year, and he said that for the students that had Macs, a lot of them, some of them were able to get it to work, but a lot of them either said, I need a virtual machine, or ended up doing a Parallels installation. So that's why I put on the survey. I kind of need to know how many of you have Macs so that we can kind of arrange that. We won't be using Inventor until a good bit later in the semester, so it's not as time sensitive. We can work through those details as the semester progresses. For those of you who have Windows, you shouldn't have any problem, okay? All right, let's talk about office hours, and let's talk about meeting times, because this part's a little bit important. I have a fairly large CAD course if you consider both classes. I think this is the largest CAD section we've ever had at Marshall. So there's a lot of people in here. And this is I think it's a relatively easy class to understand, but because we're dealing with software, there's a lot of potential glitches that can happen. So I wanted to make sure that I'm available to you all. So here's what I mean by that. There are two sections of this course. One of them meets at 11 a.m. on Monday, Wednesday, and then this one is meeting at 12 p.m. Monday, Wednesday. Well, if both sections are meeting Monday, Wednesday, that begs the question, what about Friday? Okay, what's the deal Friday? Okay, so here's what I decided to do. I've blocked off my calendar for Friday from essentially from 11 to 1 for you. This is for the people in this class. And I have also booked this room for Friday from 11 to 1, okay? Now, I can't fit 120 people in this room, I understand that, but I don't expect a lot, like the vast majority of the class to be here on Fridays. I want to be crystal clear, you do not have to come on Fridays. I'm not making you come on Fridays. That's not a scheduled meeting time for this class. You do not have to come if you don't want to. But I wanted to try and make myself available, and I wanted to have the space available for you. Like if you and a couple friends want to get together and try and work on a homework, I have no problem with that. I wanted you to have a space to be able to do so. So I booked the room so that you would have that. And I also specifically blocked my calendar off and said I'm not going to have any appointments during those times. Now, I'll be blunt. That doesn't mean I'm going to sit here for 2 hours on the off chance that somebody may come in and ask questions. That's sort of where Teams comes in. Like if you're down here working on a homework and you're like, I cannot figure this out, message me on Teams, I'll come down, okay? That's the whole point of doing this. And if I think that there's a homework assignment that may be a little challenging, I'll sort of plan on being here, okay? But you are not mandated to come on Fridays. I just wanted to make sure that I was available to you so that you would have some help. And one of the things I did is I ran the scheduling grid in the background. So I have access to a lot of reports, and Bert is in the background as the associate dean. And I ran a scheduling grid to see how many of you have classes either Friday from 11 to 12 or Friday from 12 to 1. And other than 2 students in the class, everybody is open either one of those hours or both of those hours. It's like some of the biomedicals have a physiology lab that goes to noon, but then after that, you have an hour free. So other than 2 of you, like you all have at least 1 hour open during that slot. I also have hours Monday, Wednesday, Friday from 1 to 3, and Tuesday, Thursday by appointment. Tuesday and Thursday I don't have any classes, so I can't guarantee when I'll be on campus. Like I might not get to campus till a little bit later, so that's why I just say by appointment. So if you come to campus 8 a.m. and I'm not here, that's why. Let's see. Any questions about that? Okay. So I want to make sure that everybody's familiar with the typical pattern of how the class is going to work. And I say starting week 3. I say starting week 3 because we're going to have some introductory material that we're review for the first couple weeks, and then we're going to sort of get into autopilot. So the way that this is going to work is Monday is going to be teaching day. And what I say by that is Monday, we're going to take a given topic or set of topics in either AutoCAD or Inventor or what have you, and we're going to go through sort of a guided tutorial of how to do that stuff. So like our first week, or week 3, is going to be lines and circles. So it's going to be, by the end of that, you're going to know how to draw a line and how to draw a circle, but there's going to be some other stuff built in, like how dynamic input works, how object snap works, and how a lot of other stuff works. So the idea is that through that 50 minutes, we're going to go through a bunch of stuff. Lines and circles might be the themes, but we're going to be teaching you a bunch of things in AutoCAD or Inventor. So I will level with you. I'm probably going to kill some trees this semester, because the idea is that I'm going to come in, so like this gentleman right here, we're going to go through this exercise together. I'm going to be teaching it, but there's also going to be, he's going to have a handout that he can follow along as well. So I'm going to be, like I said, killing a lot of trees, because I'm going to have a handout for everybody in here. It'll probably be a combination of either some slides on the screen or a handout, but that's kind of how that's going to go. So if Monday is teaching day, Wednesday is doing day. Wednesday, I'm going to give you an exercise that the intent is that you do it yourself. So Monday, I teach you how to do something. Wednesday, you do it, okay? So you have sort of a self-guided in-class exercise. I'm here in class, so like as you have questions, raise your hand. I don't know how to draw this line. I'm having an issue here. And then we'll go through that. The idea is that at the end of that exercise, you submit that file, and that's your homework. If you get it done while you're sitting there in class, hey, homework's done. If not, hopefully you have most of it done, so that you only have a couple steps to finish up, and you can finalize that and tweak that and submit it the following Monday. I can't say that every single assignment will be slated to be able to be completed in 50 minutes, because as we start progressing throughout the semester, some of the assignments are going to be longer than others, but the idea is that at least during those 50 minutes, we'll cover enough stuff so that you'll be able to finish the rest of it on your own. Okay? This pattern is going to continue pretty much for the rest of the semester. Weeks 1 and 2 are going to be introductory, like today. We're just going through the course operation. But starting week 3, this will be the case. During exam weeks, what's going to happen is on Monday we come in and we go through the exam review, and then on Wednesday we have the exam. And by the way, I should mention that I will probably use the term exam and skill quiz a bit interchangeably, because the purpose of these exams is more to test your abilities in AutoCAD. This isn't going to be the type of exam where you're having to memorize stuff like in a history class, like what was the year the Magna Carta was signed. It's not really like that. It's basically going to be, here is a drawing or a vignette, reproduce it in AutoCAD. So it's going to be a test of your abilities, not how much you can memorize. I won't say that's always the case, but for the most part, it's intended to be a doing exam, not a memorization exam. It's not going to be like thermo, where you have to calculate a Carnot cycle or something like that. Okay? Does that make sense? So if I use the term skill quiz, that's what I'm talking about. Okay. What do I need from you? Okay? I mentioned this, I put this slide together because I've got a lot of people in here, and I want to make sure that I'm providing a good educational experience for the people in this room. But because of the size of the class, there are some logistics that I want to make sure that everybody is on top of. Okay? So the first thing I do ask is that you do try and be on time, really mainly for your benefit. We only have 50 minutes together, and I want you to get the most bang for your buck out of that 50 minutes. I usually tell students this on day 1, but whether it's your parents, scholarships, loans, somebody's putting cash money on the table for you to be here, and I want you to get the most bang for your buck out of your education as possible, because that's what you're paying for. So I want you to be on time so that you can get the value out of that. Plus, we got a really big room, and so being able to be here on time, get your laptops powered up, fired up, ready to go, you kind of need some time to get that set up. We only have 50 minutes. I do kind of ask for those 50 minutes. So no Fortnite or Twitch or NBA or PGA Tour, your Chem 2 lab reports. If it could just be this, just for 50 minutes. And that also is for your benefit as well. Like I said on Wednesday, those in-class exercises, if you sit there for 50 minutes and do those in-class exercises, you can probably get them done, and then no homework, right? I don't know about you, but when I was an engineering student, any weekends I didn't have homework, that was a good weekend. You know, so I'm trying to structure this class in a way to where you won't have homework this weekend, or you'll have very little. But in order to do that, I do need your attention. I do need your contribution in class. By the end of this week, you need AutoCAD installed. How many of you have already got it installed and up and running? Oh, I like it. If you haven't already done so, I need you to try and get that installed by the end of the week. If you need help, come on Friday. I'll probably stop down and see at 11 and 12 if there's anybody here. If you need help, come by. See if we can troubleshoot if there's any problems you're having. The other person I want to mention is Hussein Al-Khwarizmi. He is our instructional technologist. He's our IT guy in the college. He is located in the dean's office, and his office is right next to mine. So, I can literally take a drill through a hole in the wall, and there's his office, okay? So if you can find me, you can find him, okay? He's here to help you with stuff like this. But I do have a request, okay? There's 120 people just in this class, and he's managing the IT for the entire building, for all the students with their various issues. So if you're gonna meet with him, I ask for two things. I ask that if you're gonna need him, please try and schedule in advance. I put his email address here in the slides. And if you do need to go meet him, I would ask that you attempt to at least try and install it yourself. Like, it's okay to go see him if you have problems, but if you come to see him and you didn't even try to install it, like, you know, all that's doing is taking time away from him helping somebody else. And so and plus you're engineers, I want you to try and solve some of those problems yourself. So please try and install it yourself. All right, sound good? Any questions? All right, why are you taking this class? I should have a question mark on that. That's bugging me. I feel like I'm going to fix that before in the class. I have here a slide here about the role of CAD in engineering, but I'm going to take a step back a little bit and talk about what it is that we engineers do. I'm a licensed engineer here in San. I've been an engineer for a long time. As associate dean, I go to a lot of recruiting events. I do a lot of recruiting for the college, and I meet a lot of parents and a lot of potential students, and I get asked, what is engineering? And it's I can give you some long-winded encyclopedia, Wikipedia definition for what engineering is. But I'm going to give you a simple one. We solve problems. That's it. The only difference between a civil engineer or a mechanical engineer or a biomedical engineer is we just solve different problems. That's it. Okay? But that's to get people interested in engineering. Let's hammer down to the details a little bit. What do engineers actually do? Well, a lot of what they do involves design, right? Civil engineers are designing bridges and dams and roadways. Mechanical engineers are designing machines and gears, and you biomedicals are designing pacemakers and all the bits and bobs for the biomechanical tracks and what have you. You're designing components, designing systems, designing subassemblies. This is what you as engineers do, okay? Well, you design, and to be clear, there are some exceptions to this, but engineers design, but there's typically a whole nother end involved with the manufacturing, involved with the contracting, the fabrication. Like, there's the folks designing it and the folks building it. How does an engineer communicate a design, communicate the details of a product or component to a contractor, to a manufacturer, to a fabricator? How do they do that? With drawings. And how do they produce those drawings? With CAD, okay? Drawings and specifications, they are our method of communication, okay? I am curious, is there anybody in here that's ever had any experience working at an engineering firm yet? But we have a couple of them. And what I would say is, a lot of times, if you've worked at a firm before, your company is entering into contracts with clients and whatnot. And what are they producing at the end of the day? They're producing drawings, right? Is that a fair statement? And that is largely going to be true of any field and any discipline. That as an engineer, a lot of times your product at the end of the day is the set of plans. Like all the calcs and designs necessary to produce those drawings, but that's it. If you're a mechanical engineer and you want to detail a gear or a heat exchanger or what have you, that's what you're detailing at the end, set of drawings. Drawings are our way of communicating this stuff. They need to be unambiguous. They need to be non-contradictory. They need to be complete, okay? They need to be consistent. They need to be logical in how they present information. Engineering projects are, like, there's a lot of interconnected parts, a lot of different players, a lot of different components. There's a lot of details that have to be organized. And there's some stuff that can go wrong pretty quickly if this isn't, if these details aren't accounted for. I'm going to tell you a story real quick about the September 2004 Genesis probe crash. Now, admittedly, this is probably not one that made a lot of the headlines because this wasn't really, I mean, we're not talking about, like a space shuttle crash where, there were personal injuries. This was more of a money and time issue, okay? In this situation, what happened was there was a probe that was collecting solar particles and whatnot, and it crashed and it lost a lot of the payloads. There was a lot of damage, a lot of money, and a lot of time that got wasted. And what happened was, when it re-entered the atmosphere, there was a parachute system that was supposed to deploy. It didn't. And because it didn't, it crashed, and a lot of the work was wasted. And what happened was, there were these little cylindrical switches. They're about yay big, about the size of about as round as a number 2 pencil. And they were designed that when the shuttle entered the atmosphere, they were supposed to sense it and trigger the parachute. And they were drawn upside down. And that's all it took, okay? So by having, something as simple as that costs a lot of time, a lot of money, and a lot of effort to go down the drain. So I just mentioned sort of the importance of having the data that we enter in these drawings to be very accurate. Now, I want to close this short introductory lecture with my experience and my observations from my close to 20 years using CAD packages like AutoCAD. The first thing I'll tell you is that whenever you open CAD and use it for the first time, it can be intimidating. Like it's one of those programs that maybe the first time you use it, you're afraid to click a button because you think the whole program's going to explode. Okay, it can be intimidating. But what I'll tell you is that with time, it will become a very valuable resource in your toolkit. And to clarify that, I am a practicing engineer, and I believe that what makes me a good engineer is my knowledge, my judgment, and my internal skills. But, and I want to be clear when I say this, while I don't think that CAD makes me a good engineer, it certainly increases my efficiency to communicate engineering designs to others, okay? And I am a better engineer as a result of those skills, okay? And I want that for you as well. My second observation regarding CAD is when you open CAD, there are a lot of different features, a lot of different commands, a lot of different options. I'm not going to show you all of them, but I'm not going to, okay? Because one, I don't think that's a good use of our time, and two, I don't think that you need to understand every single button and every single command in order to be a competent drafter. Mastering the fundamentals is more important. Like, it might sound silly, but we're going to learn every different which way possible of drawing a line. I mean, point, line. Just that operation, I can think of 12 different ways of doing it, and we're probably going to do all 12 ways, okay? And I don't say that to go like that seems like I'm hammering that one topic into the ground. I mean, what do you think those drawings are? They're just a bunch of lines, right? So mastering that one skill makes the rest of it go a lot smoother, okay? I don't think you need to use every button, every feature, every command for every project, but there are some that are very ubiquitous. That drawing that I showed you all, the one that was kind of nuts, I did that with maybe a handful of commands. Like, I mean, I didn't need every feature to do that. There were some that helped, which goes to my bullet point, my third bullet point. There is often more than one way to do the same thing. For example, and this might happen during our second skill quiz, maybe even during our first one, is that I might give you a vignette and say, reproduce this. And if I sat there and watched literally every screen, there's probably going to be 50 students doing it 50 different ways. That doesn't mean anybody's wrong, you know. There's probably more than one way to do just about any operation in CAD, but some are more optimal than others. For example, if you wanted to hatch in a region, use the hatch command. Don't copy lines over and over again. Even though from a visual perspective they look the same way, using the hatch command would save you a lot of time, you know. So there's often more than one way of doing the same thing, though some ways are more optimal than others. My fourth bullet is that practice makes perfect. I think at the end of this course, you will understand the skills necessary to be proficient in AutoCAD, or just CAD in general. I don't want this to just be the AutoCAD shield course, but you'll understand those skills. But if you don't use them, I don't want to say you'll lose them, but you get better with this the more you do it, okay? So, like, I learned CAD in college, but I really became good at it when I went to work. I used it more. I became more proficient at it. So practice makes perfect. My final bullet sort of loops back to the first one. Like I said, CAD can be intimidating. You're gonna make mistakes in CAD this semester. You're just going to. You're gonna make errors. They can be corrected, okay? Don't let it alarm you or intimidate you. Any mistake can be corrected. The undo button is magical. One of the most magical buttons that we're gonna use this semester is the escape key. Because if you're ever in the middle of a command, sometimes when you're using CAD and you sort of get into that zone, you don't know whether or not you're just navigating CAD or you're inside a command. And because you just get in the zone and you don't know. Just hit the escape key a few times and it'll get out of your command. The escape key is your friend. That's more of an AutoCAD piece of advice than it is strictly Inventor. But I just mentioned that for just to close the loop that any mistake or error, anything, it can be fixed. Okay, I don't want you to be scared of CAD. I want you to see it as a resource. I want you to see it as an indispensable tool. I do want to at least briefly go through the topic list for the class, and then we'll close it for the day. So I have here the syllabus pulled up. Like I said, I'm going to be killing a fair amount of trees this semester with all the handouts that I print out. So if I can avoid printing something out, I will. And so I put the syllabus on Blackboard. It is there now. So this is sort of my this is my outline for the class. For students that have had me before, which I know you all haven't, but I sort of have a reputation for being fairly, I follow my outline as closely as possible. I try and develop a really structured course. So for example, I say that exam 1 is going to be on Valentine's Day. Unless we have major weather issues, we're going to have exam 1 on Valentine's Day. Like you can pretty much take that date to the bank. Same thing with exam 2, Wednesday, March 13th. Assuming we don't have any major weather issues or anything like that, we are having that exam that day. Like I said, the first couple of weeks are going to be introductory until we get into like week 3. So let me zoom in like this. So for example, today we're just doing the overview and operations of the course. On Wednesday, we're going to come in and talk about some basics about how engineering drawings are organized, or what goes in a drawing, and then that'll help you understand like how the lectures are structured later, like why we're focusing on lines and circles, and then modifications and dimensioning, and so on and so forth. You can see starting in week 3, like we have creating lines and circles, then an in-class exercise, and then arcs, layers, in-class exercise, drawing modifications, in-class exercise, dimensioning, in-class exercise, and so on and so forth. So the idea is that the class is broken up into a series of chunks. I've made a decision that After we get to this sort of at AutoCAD Part 9, we're then going to take a break from the software. I'm not going to say we're not using software at this point, but these lectures are more about like scales and understanding some of the skills. This is more higher level stuff. When we come back from break, from spring break, we're going to be focusing on Inventor. That's going to be our focus when we come back. A lot of what we're doing with Inventor is on parts, and then we'll assemble parts a little bit later. I do want to kind of close the semester out by doing some things on stress analysis, maybe showing you how to take Inventor and turn a part into an STL file for 3D printing, because I'm sure some of you might be interested in doing that for later projects. I kind of want to show you how to do that, and some other advanced features and whatnot in Inventor, because it's got some pretty cool features. And that's pretty much it from what I had to say. I did have a couple other things I wanted to mention, but that's pretty much it for my organized content. Does anybody have any questions? Okay. I would check out the Blackboard course shell to make sure that you all are able to access it. I'll level with you, this is my first time using the new Ultra version of Blackboard, so my course shell looks a little different than that classic version. I'm still getting used to it, but one thing I'll tell you is I'm not yet sure if I'm going to track attendance this way. I may track attendance this way, or I may just manually upload it, but one thing I'll tell you is that you will know what your attendance grade is throughout the semester. I'll make sure that you're aware of that. What I'll probably do is upload attendance once a week. So I may try and do it today just to make sure everything's working well, but I'll make sure that it's uploaded pretty regularly. Inside the course content folder, the way it'll work is I'll have a folder for every week, and inside that folder will be the lecture notes, the homework assignment, or the exam, what have you. It'll all be just week by week by week by week. And that, I think, is my last thing, other than I'm going to pull the QR code up one more time. Any questions? All right, well, I'm going to pull the QR code up one more time in case anybody didn't get it. And, what did I want to have you done before the end of this? What did I want you to have done before the end of this week?
Install AutoCAD.
Install AutoCAD. So if you haven't already done it, get to work on it. I'm going to stop my recording. I will see you all on Wednesday.